So the question number one is an insulated metal sphere of the radius r is situated in a vacuum. The charge q on the sphere may be considered to be a point charge at the center of the sphere. State the formula in terms of r, q for the potential v of the surface of the sphere. So in chapter electric field, we have done that voltage, the potential is V is equal to 1 over 4 pi epsilon naught Q divided by R, and R is the distance, but for the surface, the distance is equal to radius. So this is the potential at the surface of the charged sphere. Next part is define capacitance and hence show that capacitance of the sphere is given by the expression C is equal to 4 pi epsilon naught R. So the ratio between charge of one plate and potential difference between both plate is called capacitance. This is the definition. Now we have formula V is equal to Q over 4 pi epsilon naught R for the charge sphere, and for the capacitance Q is equal to CV. Now replace this Q with CV, V cancelled with V. So the formula becomes 1 is equal to C divided by 4 pi epsilon naught R, mean it is C is equal to 4 pi epsilon naught R. So this is the capacitance of any charged sphere. Next is an isolated metal sphere has the radius 45 centimeter. Use expression to calculate the capacitance in picofarad of capacitor of the sphere. So sphere capacitance is 4 pi epsilon naught R. 4 pi is 22 by 7. Epsilon naught R value, page number 2, question paper 8.85, 10 power minus 12, and the radius is 0.45. So after calculation, the answer is coming 5 into 10 power minus 11, but we have to write in pico. So it will be 50.0 into 10 power minus 12 because the pico is minus 12. So the answer is 50.0 picofarad. Actual answer is 10 power minus 11, but we will multiply it by 10 power minus 1 to make it 10 power minus 12. So similarly, we will multiply with 10 power plus 1, so it becomes 50. So 5 into 10 power minus 11 will be written as 50 into 10 power minus 12 because pico is required. Next, the sphere is charged with a potential difference of 9 into 10 power 5 volt. This is the initial voltage. The spark occurs partially, discharges the sphere so that the potential is reduced to 3.6 10 power 5 volt. So initial voltage, final voltage is given. Question is energy of the spark, mean energy which is lost, which is dissipated. So look, energy formula is 1 by 2 CV square, but we have to calculate the difference of the energy, initial and final. So it is 1 by 2 C1 V1 square minus 1 by 2 C V2 square, 1 by 2 C common, V1 square minus V2 square. V1 is given 9 into 10 power 5, so it's square, and V2 is given 3.6 10 power 5, it's square. So when you will calculate this, the answer will be 17. So we will write it 17.0 joule. So you have to calculate the difference of energy because the energy of the spark is the loss of energy, dissipation of the energy. Next, ratio between charge of one plate and the potential difference between two plates is called capacitance. This is the definition of capacitance. Now the next three capacitors of capacitance C1, C2, C3 are initially uncharged. They are then connected in series to a battery as shown in the figure. In the battery applies a potential difference V across three capacitors. Show that the combined capacitance C of the capacitor is given by 1 over C1, 1 over C2, 1 over C3. So we will start in series voltage divides. So V1 plus V2 plus V3 is equal to V. But in capacitor, Q is equal to CV, mean V is equal to Q by C. And in series, current charge remains same. So we will replace V, Q by C. This is Q over C1 plus Q over C2 plus Q over C3. So all Q's are cancelled because charge remains same. So the final shape of the formula will be 1 over C, 1 over C1 plus 1 over C2, 1 over C3. So this is the formula when the capacitors are connected in series. Now the next part, the battery of EMF 12 volt and negligible internal resistance is connected to a network of the capacitors and resistors as shown. The capacitor have capacitance 200 and 600 microfarad. The switch has two positions, A and B. So we can connect switch either with A or with B. When switch is connected with A, both capacitors are in series. But when the switch is connected with B, this 600 microfarad capacitor is disconnected from this charging circuit and connected with the resistor for the discharging. So switch is moved to the position A. Move to A, mean both capacitors are in series, 200 and 600. The combined capacitance, series formula, 1 over C1, 1 over C2. So 1 over 600, 1 over 200, it becomes 4 divided by 600. So C will be 600 by 4. The combined answer is 150 microfarad. When both capacitors are in series. The charge on 600 microfarad capacitor. Look, in series, the charge remains same. So we have to calculate the total charge. So the total charge is equal to total capacitance in the total voltage. Total combined capacitance is 150 micro 10 power minus 6. And the total voltage supplied by the battery is given 12. So the answer is 1.8 10 power minus 3. And the next, the potential difference across the 600 microfarad. Q is equal to CV. V is equal to Q by C. So the charge in series remains same, 1.8 10 power minus 3 divided by capacitance of the 600, which is 600 10 power minus 6. So answer is 3. So one capacitor has 3 volt. So definitely the other capacitor will have the 9 volt because the total is 12 and one is at 3, the other will be at 9 in series voltage divides. Next. The switch is now moved to the position A to B for discharging. Calculate the potential difference across 600 microfarad capacitor when it has discharged 50% of its initial energy. Look, energy is equal to 1 by 2 CV square. 1 by 2 C. During discharging, capacitance of the capacitor remains same. So E directly proportional to V square. So we can write ratio E1 over E2, voltage 1 square over voltage 2 square, mean potential. So suppose initially energy is E, and then remaining 50%, mean 0.5 E. Initially, it has 3 volt, and finally required. So E cancel with E. So this is 1 divided by 0.5, 9 divided by V naught square. So V square is equal to 0.5 times 9. So 4.5 under root, the answer is 2.1. This is the voltage after 50% loss of the energy. Now, the next question is question number 3. A student set up the circuit as shown in the figure to measure the charge on the capacitor C for the different value of the potential. The variation with the potential V and the charge on the sphere is shown. So if these points are plotted, state and explain the figure, how figure indicate that there is a systematic error in the reading of one of the meter. Look, the best fit line is not passing through the region, so it has zero error, which is systematic error. Line is not passing through the region because Q and V both are directly proportional, and the directly proportional line is straight and passing through the region. So this is the systematic error. Determine the capacitance in microfarad of the capacitance C. For this graph, the gradient of the graph is capacitance. So take any 2 points and calculate the gradient. Suppose gradient is at the y-axis, the change in the y value is 15 into 10 power minus 3, and the x-axis value changes 5.5. You can take any two value. So the answer is coming 2.72 into 10 power minus 3. But we have to write this in micro, micro mean 10 power 6. So we will write 2730 microfarad. This is the actual answer in terms of minus 3, but to make it minus 6, we will write this answer. Use the answer in B to determine the additional energy stored in the capacitor when the potential difference increase from 6 to 9. Again, difference of energy is required. So 1/2 C V1 square minus V2 square, because difference of energy required. So 1/2 capacitance we have calculated. Initial voltage is 9, so 9 square. Final voltage is 6 square. So after calculation, the answer is coming 0.061. Okay, beta. Next question. Question number 4. Define capacitance. So same. It is the ratio between charge of one plate of the capacitor and potential difference between both plates of capacitor. Next part is use the expression for the electric potential due to the point charge to show that isolated metal sapphire of the diameter 25 centimeter has capacitance this. So we have already done that. The capacitance of the charge sapphire is 4 pi epsilon naught R. So 4 pi value, epsilon naught value from the data sheet, 8.85, 10 power minus 12. Radius, half of this, but in meter, so 12.5 divided by 100. So you will get answer approximately 1.389 into 10 power minus 11, which is close to this answer. Now the B part, 3 capacitors are capacitance 2 microfarad, 3 and 4 are connected as shown. So look, 4 and 2 are in parallel. So in parallel, capacitance is added by C1 plus C2, just added numerically 3 plus 2, it becomes 6. And this is 3, so 6 combination and this 3 capacitor in series. So the combined capacitance of the 3 capacitors, so 1/C for series, 1/C1, 1/C2. So the combination of the 2 parallel is 1/6. And the next is 1/3. So it becomes 3/6, means 6/3. So answer is 2. Next, the potential difference across the capacitor of the capacitance 3 microfarad. Determine the potential difference. Look, charge Q is equal to CV. In series, when charge remains same, then capacitance is inversely proportional to V. It means the product C1 V1 is equal to C2 V2. So when the total capacitance is 2, the voltage supplied is 9. So 2 total capacitance, the voltage is 9. And when the capacitance is 3, what is the voltage? Answer is 6. Mean This capacitor is getting 6 volt, and this combination is getting 3 volt. It becomes 9 in total. Next part, the positive charge stored on the capacitor of the 2 microfarad. Look, Q is equal to CV in 2 microfarad over here. So capacitance 2 into 10 power minus 6, and its voltage is 3. So the answer is 6 into 10 power minus 6. So 6 microcoulomb. Next question. State 2 uses of capacitors in electric circuit other than for the smoothing of the direct current. Yes, it is used for time delay circuit to store electric energy. It blocks direct current. So you can write any two. Now the next is the combined capacitance between terminal A and B of the arrangement shown in the figure is 4 microfarad. Total capacitance of these 4 is given 4. 2 capacitors each have capacitance C, and the remaining capacitors each have capacitance 3 microfarad. So this is 3 parallel, it becomes 6. So this combination 6, this C and C, these are connected in series. So series formula is 1 over C, 1 over C1, 1 over C2, 1 over C3. So 1 over C mean 1 over total, it's 4. 1 over C1, C, second C, 1 over C, and the third combination 1 over 6. So it becomes 1 by 4 minus 1 by 6 is equal to 2 by C. So 1 by 4 minus 1 by 12, it's 1 by 6 is 1 by 12. So C is equal to 24, mean the capacitance of each C is 24 microfarad. Now the next, calculate the magnitude of the total positive charge transferred to the arrangement, mean total charge of the circuit. Q is equal to CV. Total capacitance, 4 given, 4 into 10 power minus 4. And the total voltage is 12. So it's 48 microcoulomb. Use the answer to state the magnitude of the charge on one plate of the capacitor C. Look, in series, charge remains same. So definitely 48 microfarad will appear on the plate. Now the capacitor of capacitance 3 microfarad. So this 3 microfarad capacitors are connected in parallel. In parallel, current divides, charge divide. So equally divides 48. So it is 48 by 2, mean 24, half of. And the next question number 6 is, capacitor consists of the 2 parallel plate separated by some insulator. Suggests why when the capacitor is connected across the terminal of the battery, the capacitor stores energy, not the charge. Now look, each plate has same magnitude of the charge, but opposite in sign, opposite in polarity. So one plate is positively charged, other negative. So the net charge becomes 0. But during the charging of the capacitor, work is done on the charges, so shift them to move them from one plate to another, and that work is stored between the 2 plates in the insulator as energy. So this is the reason energy is stored, charge is not stored. Next, define capacitance. We have done. It's a ratio between charge of one plate of the capacitor and potential difference between both plates of the capacitor. And the next, the capacitor is charged so that the potential difference is V0. I mean, this is the original. The capacitor is then connected across the resistor for a short time, mean for discharging. It is then disconnected. The energy stored in the capacitor is reduced to 1 by 16 of its initial value. I mean, this is the remaining energy after discharge. In time t, determine in terms of the V0, the potential difference across the capacitor. Again, formula, E is equal to 1 by 2 C V square. 1 by 2 C constant. So E directly proportional to V square. So ratio E1 over E2 is equal to V1 square over V2 square. Initially energy stored E, remaining energy 1 by 16 E given. Initially voltage is V0, so square, and the new potential required in terms of V0 is X, so X square. So E cancelled, it becomes 16 is equal to V0 square over X square. So X square is equal to V0 square over 16, under root of both, so it becomes V0 by 4. So this is the remaining potential in terms of V0.